In the last video, I told you about the sigmoid function. Sigmoid function is an example of activation function that we use a lot in neural networks. There are many types of activation functions. Sigmoid function is one of them. Then there's another one that is very popular nowadays, ReLU. So I'll talk about it later when we use it. So you just keep this in mind. Now, this is a very simple neural network. These are the inputs over here, and this is the output. Between that, there is a layer. This is the layer between the input output is always called the hidden layer. So there is only one hidden layer in this neural network. So we can have two hidden layers, three hidden layers, four hidden layers. So it all depends on us. So in this, I have just have one hidden layer just to make to explain the concepts and keep things simple. So once we pass the data from the input through the hidden layer to the other side, it's known as forward pass. So if we have two hidden layers, then this input, once we pass the data through this hidden layer, we will have another intermediate output, and then we can again forward pass it through that second hidden layer. And if we have got three hidden layers, then the output from the second layer is then passed to that third hidden layer, and then again we have an output. So this is how we are going to train our neural network. As you see, first the data is passed to the first hidden layer, and then if we have got second, then the data is passed to the second hidden layer, and then if we have got third hidden layer, the data is passed to the third hidden layer. So this is known as sequential layers, and this type of neural networks are known as sequential neural networks. So there are non-sequential neural networks also, but for the time being, we just stick with this thing. There are many types of neural networks nowadays. One type that is very popular is the transformer, and we have got recurrent neural networks. So when later on we can discuss them, but for the beginning, let's start with this very simple feed-forward neural network. This type of architecture in which there are hidden layers, and the input is passed to the first hidden layer, then that intermediate output is passed to the second hidden layer, then intermediate output path third it is no, and then we have got the outputs known as feed forward neural network. So let's do some programming. So this is a sigmoid, as I explained in the previous video. Sigmoid is 1 over 1 plus exponential x. So whatever number you give it, it will all output between 0 and 1. So if we have got minus 10 number give it, then it will just be close to our 0, and if it is plus 10, it will be close to 1. So this sigmoid is basically a vectorized sigmoid because we have used numpy, so that we can take sigmoid of matrices and vectors. And the forward pass, this is the forward pass that we make through layer. As I've said, this is one layer. So it's also known as a dense layer when we have this type of forward pass. So this matrix multiplication, numpy dot matrix multiplication. This is the input into weight matrix plus bias. This is also a vector or matrix, depends. So let's say we have got only one hidden layer. So in that case, let's start with an arbitrary input. We have got ones matrix consisting of ones. It has got 20 rows, 15 columns. 20 rows means we have got a sample of 20. 20 samples. We got a mini batch with 20 samples, and we are going to use these 20 samples to build our neural network. And we have got 15 columns. So 15 means, as in the previous video, if you have seen on the features, so we had 15 features, so 15 columns. W is the weights. Weights are adjusted according to the data. We start with random weights. We can start even with 0, 1, whatever weight we want. And after that, first pass, we compare the output with the actual output. And in case of discrepancy, then we adjust the weights. This is known as back propagation. So in the next video, I'll explain to you back propagation in detail. Right now, we are talking about forward pass. What is forward pass? So these are weights, same number of columns as that rows as the columns of input, and the 3 is the output. And bias is we had these we if you had some concept about regression, so bias is just to shift the output up and down. So this is bias. So these are all parameters, W and bias, and we adjust these weights and bias according to the data. So that this is how we're going to then approximate the function that represents that data, and we can use it for. So this is a forward pass is simple, and p dot mat multiplication x w. This is forward pass one. But let's say we have got two hidden layers. So the input is this one, same 15, and W1 is that first layer weights, and the B1 is the first layer bias, and second layer weights, and second layer bias. So we just then make forward pass, right? So this the input is then again passed, and then we have this output. So I hope you are now clear about this forward pass and what is the feed forward neural network. Let's run it. Right? You see, we have got these as we have done one hot encoding. So these are matrices, these are 3 columns, and these are rows. So I hope you have now understood what is a forward pass and how we build feed forward neural network.